Hello, we are Bull Risk and we are tackling Challenge 13, Risk Mitigation Recommendations.
Our team consists of a BI developer, data scientist, risk manager, business analyst and project controls professional.
The output of this challenge is an easy-to-use data visualization dashboard. This will be presented by the project controls assistant to the project manager and functional risk manager. It will provide a threshold figure which should not be exceeded for a mitigation. This will help inform the functional risk manager and project managers go or no-go decisions.
When building the machine learning model, we needed to identify data of poor quality to exclude. Furthermore, we decided that our dashboard would only present live risks. We decided to add further functionality to identify data quality issues which would benefit the functional risk manager and improve future output.
We built a fully automated cloud solution for taking new risk registers and then running a risk likelihood prediction model and updating a Power BI dashboard. From the point of view of the user, they simply upload an Excel file to a Google Drive folder and then refresh the data source in Power BI. Behind the scenes, we have a three-stage infrastructure. The file upload triggers a Python service which then uses a logistic regression model to classify the risk. The Python then updates a SQL database which is connected to a Power BI dashboard. This process is automated and allows the user to apply machine learning models without any effort.
In order to create a machine learning model, we had to do some data manipulation first. We have selected only threats observations, excluding the opportunities. We have then split the data frame in two data frames: historic risks, which we can feed into the machine learning model, and open risks, which may or may not happen in the future, the ones we want to provide advice on. We have selected only columns useful to train the model and improve the prediction. We have also cleaned the data from nonce values, risks with 0% likelihood, data quality issues. Finally, in order to have a balanced and less biased training dataset, we have sampled the same number of not occurred and occurred risks. We have therefore instantiated a machine learning logistic regression classifier, trained it with historic data, assessed the classifier's performance to make sure this was good enough, and once we were happy, we have used the model to estimate the new probability of the open risks to happen anytime in the future. These new likelihood values are now part of a new risk register written to a SQL database and then read by a BI dashboard.
The risk dashboard has been designed to show the user an interactive breakdown of risk items combined with our machine learning model output, identify opportunities to mitigate risks according to the scoring, threshold budget, and category, to name a few. Looking at the dashboard, the model PID score gives a holistic view of risk severity. The model PID score is compared against the initial PID score, which will inform the user of the risk items to prioritize depending on severity. The dashboard is dynamic in that you can click on the visualizations to filter the surrounding dashboard. This means you can click like so, which will focus the data shown in the report. The dashboard allows the user to see the predictive data at a risk item level, which can then focus the main visualization above to show positive or negative effects on the mitigation budget.
When understanding the results gathered, our dashboard clearly provides each mitigation a threshold budget. This was presented on the main table visualization. This budget should be compared with the estimated cost of a mitigation to give a go, no-go decision.
So we have selected only columns useful to train the model and improve the prediction. Those columns are risk categories, phases where those risks are at risk of happening, post-mitigated probability, and the risk status, which means has this risk happened already? These have been the fundamental variables to build the model. As a room for improvement, it would be great to have in the future some further parameters which can help increase the model accuracy.
Thank you for viewing our presentation.